All right, I'm live with assimilating Rust code today, and I already have my screen shared here. And I'm going to dive right into an important topic, which is how to containerize your Rust application. And what I wanted to do was just get a whole end-to-end process working where I containerize something. So I'm going to first start off in this repo, Noogie Rust MLOps template, and I'm going to go into this repo and open this up. And one of the things that's, I think, a good idea about containers is that you can use them to deploy to, other environments like AWS App Runner, etc. And that is actually an amazing use case for a container, because the containerized environment uh, can work really well with cloud-based deployment. But I think it would be fun today to more focus on building just like a really tiny container. So we can see here I've got some containerized Rust examples here. And what I want to do is just put a new section in here, and we can put it right here, and we can just say, containerized Rust, containerized Rust examples. And I guess the first thing to do when you're doing a containerized Rust example is to make a new project. So I'm going to say, cargo new, and we'll call this tiny Rust or ty Rust font, tiny Rust container. Does that work? Or rs tiny Rust container. Oh, that one is the one word. Tiny Rust container. So I'll put this here. We'll do that. Next step, cd into there and cd into that. There we go. And cd into this, and then copy a makefile in there. So this would be step one. Copy a makefile and Docker file. I think I have two of these somewhere. So let's see here. We got, well, I have this web Docker here. So I'm going to say from web Docker. Those are probably a decent starting point. So I'm going to see CP here, web Docker, and we'll say Docker file. Oops, here. And then I'll do makefile here. There we go. So I got those created. Now let's look at those files and let's tweak them a little bit. So we got a makefile, which looks good. Run Docker, maybe. This looks like a good starting point. And then for Dockerfile, see, this is what I wanted to play around with, was that, I mean, it is nice that I can run a web service. I mean, maybe that's what I do. Maybe I just do with a web service right now to start with, and go from there. I mean, I guess the Docker file is already set up for it. Now, this is kind of an interesting like style, which I'm not 100% sure when this occurred. But if we say from Rust latest as builder, what's kind of interesting about this is that I don't see any other examples here. But basically, if we go to Rust Docker example, we can look at the documentation. So let's actually add this. Let's actually add here, and we'll say like references inside of here. So references, because what I'm very curious about is how to actually enhance this a little bit we'll just say like the notes for a Docker container, notes for Rust Docker container, because what is kind of cool about this is that if you look at this Docker file, this does the work, but this is the target. And so what's very fascinating is that you can build these really tiny containers. And so all we need to do here for the command is I'm going to change this command to this. We'll say tyrs container. That'll be the binary that's created. And then for the app as well, we'll call that. We'll say the tiny Rust container. So that looks good. So then the only other thing we need to tweak is the dependencies, and I think that's, and I can just look at the dependencies for that other project I had, would be this Actix is probably what I care about. And we'll go here. And let's see if we can just get a hello world working here really quick. So we got that. And then that looks like it's probably enough. And if we have a main file here, we could also, I guess, create a lib file. So let's go ahead and do that. We'll say touch source lib.rs. We have the gist of everything working. Now let's again go back to the Docker Rust file and see what this says. So how to use. So start a Rust instance. The most straightforward way to use this is just to do like a regular Docker file. So I see this. You just say, okay, let's install some stuff. And that looks straightforward. And then you go ahead and you build it. Now, this is what I've been very curious about. This creates an image that has all of the Rust tooling for the image, which is 1.8 gigabytes. If you just want the compiled application, which is really cool. So basically, this has the tool chain for us. But look, you can do from Debian Bullseye Slim. Now, what is this one? Let's look at, what do I have here? From Debian Buster Slim. Now, is that the latest one? What is the latest version here? Let's look here. What's the latest? Buster, Slim Buster, Slim Bullseye, tags. Let's look at the tags here. So we have the latest tags. We have Slim Buster and Bullseye. Why do I not know the difference between Buster and Bullseye? What does that mean? Is it just a version of Debian? Is Buster the latest one? We have Buster, Bullseye, Bookworm. Which one's smaller? So this one's the smallest one. And then we have latest. But Slim Buster, I'm assuming Buster versus Bullseye. Let's Google that. Like Slim Buster versus, exactly. What does that mean? What's the difference? Which one should you use? Okay, I guess just the latest. That's just the version. I mean, it would be nice if it told you like some kind of number. It's a little bit confusing. I'm assuming Slim Buster is the latest one. And if we look at the documentation here, it's going to say Bullseye Slim. Bullseye Slim. But if I go to this, we have Buster Slim. And if I look at the tags, Buster. I'm assuming Buster is the latest one. So we'll stay with that. And then we do this and we build out this application. Now, what's really cool about this, I guess if this was like a command line tool, is that this would actually be able to make this really tiny installation. So you can see that some shared libraries may need to be installed in the line above. I see app install extra runtime dependencies. This will create an image that's less than 200 megabytes. If you switch to Alpine-based Rust, you might be able to save another 60, and then you compile your app inside the Docker container. There may be occasions where it's not appropriate to run your app into a container, so you can compile it. That's very interesting. The Rust comes in different versions. This image doesn't contain the common packages. And then Alpine, this is based on popular Alpine. It's so small, it's 5 megabytes. There are some issues though that go with this. Okay, so this is really good documentation, and I think that helps me, kind of go forward. So basically, all I need to do here is go over to this lib file, and we can just create maybe like a library. And what's something I could do inside of here that would be kind of fun to import is why don't we pick a different type of Rust function here. So we can say like utilities or a library or a microservice in Actix. So I would say probably like reverse a string maybe. Let's do that. Let's just see like build a function that reverses the string. There we go. Reverse a string. And then we can say, how about one that converts a string to Pig Latin? So build a function that creates Pig Latin from a string. There we go. That looks good. And we'll build another one that builds a function that converts a string to binary, return binary. No, actually, let's do build a function that converts a string to basically a to ones and zeros. There we go. That's more what I meant. Okay, we got this. Now let's go back to the main file, and we can basically say a microservice for processing strings. Looks pretty good. And so I could look at my other example here, just take some notes. So this is probably what I did something like this before. So I'll just copy some stuff in here. That looks good. And then inside of this, we'll do you don't need to import it actually. I guess I could use that. Primary Pig Latin reverse. And create a function that returns hello world message and explains what microservice does. All right, so that looks pretty good. Let's do a format here. Okay. I mean, that's pretty nice that it will generate that for us. And then we just basically create a function that reverses a string. I don't know why this is having issues here. That returns or create routes for the reverse. Yeah, so let's just make each one of them. So we have a reverse input. That looks pretty good, right? I can just pass it in as a URL. And then we'll build another one for Pig Latin. Looks good. And then we build another one for binary. Okay. Now let's run it. Register those services. So service hello, right? There's 4 of them. And then for the bind, we'll do 0.0.0 and 0 80, and then just a little bit of boilerplate code. And I believe that is it. If I remember correctly. Let's look at the other service that I created earlier. Well, yeah, looks good. So let's do a format. See if that works. So lint. If lint passes, we're in good shape. But Rust is very opinionated. That's the thing about Rust is, boy, the linter really punishes you. I mean, it's good. It's like a personal trainer to build amazing code. So it found some problems. Not surprised. And what do we got here? So we have all kinds of problems. So we have first previous import of the reverse here. Oh, yeah. See, it does weird stuff like this sometimes where like it doesn't mind doing weird stuff like this. So we'll just add it to it, reverse it. Big Latin. I think I should do underscore like that. I think that's like the proper way to do it. Big Latin it, binary it, something like that. And then we just have to add the its to this. I think this is a good way to deal with name collisions with web frameworks between the route and the method you want to use or function you want to use. And we just try to lint it. Whoa, that was easy. Wow. Okay, so now I can just run it. I can just do make run. Now let's see if this works. Should compile our Rust code. Running the service. Nice. And then if we open it up in a browser, we should see, hello world, this is a microservice for processing string. Look, it even made our documentation for us. So we can reverse a string first. So we can say reverse, we could say the rain in Spain. There we go. That was pretty cool. And then we also could do Pig Latin. So we could say Pig Latin, and we'll call this, we'll just say Marco Polo. And it comes up and it puts some Pig Latin. I actually don't totally understand Pig Latin. I think it just injects things like this or hello Bob. And it just puts like an AY inside or something like that. I don't know. That's how you do Pig Latin. Hello Bob. And then the other one, we want to make binary. So we just do binary here, and we just see all of our, ooh, look at this, ones and zeros. That's pretty cool, actually. So you can see here, like, look, we even printed out things as well. So we have a working microservice here, and I can even check this thing in. Say get status, and I can even go up a directory to say git add everything, git commits, adding working microservice. Service. Okay, we got this thing cooking. Everything looks good here. The part that I think would be the next part is, okay, now let's do Docker, right? So in order to containerize this, it's actually not bad. All we have to do is look at our makefile again and notice that we have to just say Docker build. Instead of seeing fruit, we're going to call this strings, and then the same thing. So pretty easy to do is we can just say here, make build. This will build. Whoa, let's back into this container. Say make build. Now you can see here, like I believe that the original container is close to a gig, but that's just the build system part of the container, right? That's just the Rust base image. But what's nice, because what's painful is when you don't need that, but it goes into your target container. What's nice though, when you use this builder, is it actually will create a much smaller container here, and I believe it's under 100 megabytes. We're about to find out. Okay, it's updating the crates here, putting everything inside. Okay, so now if we just go here, we type in Docker image ls, notice that this particular container is only 94 megabytes, right? So this is not bad. I mean, this really is a pretty cool story. And you can see like bash, creates Docker. The final container is very small, i.e. 94 megabytes. I actually have deployed this before to AWS, so I know it works very well. And then if I want to run it, we just go to the makefile and we run this command here. So I just say make run Docker. It should now run it via Docker, and the same thing will work. There we go. And then if I go through here and I say reverse here, and I say today, there we go. So not bad. So it's actually quite trivial, in fact, to get the containers working with Rust, and the result is very good. So I think another thing in the future I'd like to do is play around with building really tiny command line tool based containers. But at this point, this is good to go. If I wanted to push this, for example, to AWS, we can just put a note here that says the end result is that you can easily test this web service and push to a cloud vendor like AWS and AWS App Runner. Right. That's it. That's a good example project for today. And the Docker file might be the most important part. I'll just put that into the notes here. And we can even put this here, Docker file, put that in there. We'll just put a note that says, note that the Rust build system container, which is about 1 gigabyte, is not in the final container image, which is only 98 megabytes. There you go. Good to go. So I'm going to go ahead and say get status, and I'm going to go up a level here, get add, and we're going to get this adding file container. All right, good lesson for today. I'll be back for this particular topic in a couple weeks.